Alright, let's do it. It's getting recorded. And he's looking for us. So I just Very good. Alright. Okay, so we can get started again after much, fiddling with stuff, because somebody decided to lock down the PC again, and I could not get into. I can do it in Windows. I can teach this whole class out of Windows, on the desktop. But that means, I'll have to log into some machine for the assembler, and also there won't be any screen recording. Since I'm going to do screen recording anyway, using my laptop, it's just as easy. So it is right, we could have used a live stream if I boot into Windows, but then I still have to find a virtual machine to run Linux code. So I might as well just combine the two into one. All right, so this is our second last class meeting, because Tuesday would be the last class meeting for lectures. And then after that, we have the final exam on the following Tuesday, and that's it for the whole semester. So that means, if you have any questions to ask, this will be a good class to ask, and the next one. Yes.
What about Thursday?
What about next Thursday? That's the first day of final exam, so we are not meeting on that day. Okay. Yep.
Is your office hour going to be the same?
The office hour will be the same as before. It is from 9:30 to 10:30 in the morning. So I maintain the same office hours, throughout the final week.
Even Thursday? Next Thursday?
Even next Thursday is a little different because I do have a final exam for another class during that time. But you can find me in room 152 after 10:30. So for the most part, I will still be in my office, from 9:30 and up. Okay. All right. Are there any questions? Oh, I was hoping there's no question, like then I can just say class dismissed. Yes.
Actually, I was just making sure that the assignment was due on Wednesday, correct?
The assignment is due next Wednesday.
Right.
It is due on Wednesday. Was it? Oh, okay.
What are we going to do on Tuesday?
What are we going to do on Tuesday? We'll have a practice final exam on Tuesday. And I have thought about it a lot, about changing the format of the exam. What I can do is I can separate, those, coding questions. So instead of having one single program and you have to fix, like 3 subroutines all at the same time, I would just, separate it back out and have, one program to fix, one program to fix, one program to fix, and they're all individual, they're all independent. So that should make it a little bit easier to, work on the code.
Like a combination of the first and second one, then? Is that what you mean? Because the first one was kind of 4.
No, it'll be about the same as the second exam, except it's not one single program, and the functions won't have any interdependencies. So you have one function to debug for each question, one function to debug for each question, and you don't have to fix this one first, and then you can work on the next one.
That's good, because then we should be able to skip the ones that we're not sure of and come back afterwards or something. I think
Yeah.
that would be
Yeah, exactly.
helpful, yeah.
Yep. And I'm hoping that because we talked about the second exam, well, I didn't really talk about it, but the answer of the second exam was disclosed. Did you guys have a chance to study, to look at the solution of the second exam? No? No, the answer was disclosed. The code that works is disclosed. So what you need to do is to compare the question, the code in the question, the solution, and also your answer. If you compare those 3 files together, then you can see where how you can see where the mistakes were and how you're supposed to fix them.
How TAC writes a test, lesson 1.
Write a program, make it work, then make it not work again.
Sometimes it's harder.
Well, I try to use the same mistakes that people have made in the class. For instance, a lot of people make mistakes about the length of the instructions. Where CMPB is expected, a lot of people use CMPL, And that worked because a lot of people allocated more bytes than they should in order to kind of force the whole thing to fit. Okay? But in the second exam, I made sure that I do not leave any space like that. So so mixing up CMPB and CMPL would not work. Yep.
Wouldn't being inspired from our errors be some sort of copyright infringement somewhere?
You can patent your bugs. Yes. Yep.
Can you just make it easy and just have us write C code into assembly instead? That's so much simpler.
That just gave me an idea. That usually
let's
is
not
a good
do
thing. So you guys have to thank Christ for giving me these ideas.
I don't think we're going to.
I think I can give you like perfect code to begin with, and you guys have to write the C version of that assembly code.
No.
I'll give you the assembly code, you give me the C version.
If it can be pseudo C, you've got a date.
That would be, I have never thought about it that way. Thank you. That's a brilliant idea.
As long as it doesn't have to be perfect C, I'm all
Yes.
on board.
I have a better idea. You give us the correct assembly code, and we have to give you the correct assembly code.
Where's the temperature?
That's also a great idea, but not for this semester. Because what I can do, in a different semester is I can cover 2 different architectures. So I can give the students, the instructions or the assembly code for one architecture, and they have to translate that to another architecture.
That would be easy.
That'd be a math class.
That would be kind of.
It depends on which 2 architectures I pick. AMD versus Intel. Yeah, I think it's not too difficult.
ARM versus
ARM versus AVR
Power
would be
PC.
easy too. Yep. Okay, well that's some ideas. Good thing I'm recording, because if I were not recording, I would have forgotten that whole thing about decompiling a program and making a question for this class.
Where's the answer for our exam located?
For exam 2, okay, let's go to the website and take a look.
How much more material do we have to cover?
We don't have anything else to cover. We are done in terms of the coverage of material. It's really just a matter of going back and use more examples to illustrate those concepts at this point.
Okay.
Yep. But before that, let's go ahead and take a look at the solution of the second examination, which I sent out as a news article or a news item. And it should be here somewhere. Solution of exam 2.
How about the solution for the final?
I don't have it yet because I don't even know what is in the final.
Having to rank at the last minute. Oh, don't have the answer.
Okay, let me
We can
say
do you a
this.
really huge favor. We'll give you the solution, and you write the final.
But you have already done it because of your homework assignments.
We should work as a group project to write the final. All of us.
Group projects.
I actually did that with my whole class. A friend of mine, we finished the class and I was writing the final.
My English class already gave us all the questions. We just have to go in final day anyway, just the questions.
Okay, and nobody can see that except me.
Oh, so you went back.
Okay, so this is the answer. Remember that email that I sent a long time ago? If you have deleted that email, that's okay. It's still on Moodle, so there's no excuse of no, I cannot find it anymore. Okay. So in this case, I have this is the full implementation. This is the correct version of the code. So what you need to do is to compare this code to the code that is provided in the question itself. Then you can spot all the errors, where they are. Yep.
Can you dip it with the question?
You can vim diff. You can use vim diff to vim diff it. You mean here? I don't think this screen has enough width to really use it, because if I vim diff it, several times, you guys want to try that?
Well, then we need our one on.
Can't hurt to try.
I can do it. I can try it.
I guess so.
And I have to spot exam 2. And decompress that file. And then switch back to my command line. Okay, so I can do some vim diff I will show you the answer. So the answer is on your left-hand side, and then the question itself or the wrong code is on the right-hand side. So this is how VimDiff works. It's because of the font size that I use and because the screen is really kind of magnified, I cannot really display a whole lot at the same time. Okay, so the first part is here. I think with all the syntax highlighting, actually it makes it harder to read. I don't know how to change that. The syntax highlighting I can turn off, but the div, coloring is a different story. I don't know how exactly to turn that off. Let's see, take a look at colors. Is that any better? No? About the same?
Yeah.
1, 2. 1, 2.
Okay. No? Tango? Linux console, I think this is the best. This is better. And then we have RXBT, no. Custom, no. Okay, we'll just use a Linux console. Like
So you
that.
can read words.
Yeah, that's the best I can do, without actually spending more time to kind of deal with the color thing. Okay, so this is the first thing. Okay, first thing is base is a 1 byte thing. The wrong code, which is here. Okay, let me highlight this portion here. This is the wrong code. The wrong code is just moving base using move long into EAX. That is incorrect, because if you did that, you would move the 1 byte that you want, and then the 3 bytes after that too, into EAX. And in this case, it is bad because we are using EAX for multiplication, which means the other 3 bytes that you put into EAX is going to mess up the multiplication. So the correct solution is on your left-hand side. Let me use line numbers. So let's see. Yeah. So in terms of the correct version, line 78 to line 79 is the correct solution. I just put a 0. I move long 0 into EAX first, which clears out all 32 bits. And then I use move byte to move base into %AL to initialize the 32-bit register, but only the least significant 8 bits were actually in use in this case. It's perfectly fine okay in this case because that 1 byte is unsigned. If it were signed, I could not use this method either. So that's one, that's the first thing. The second one is here, which is really, really hard to see. I'll just go ahead and highlight it, because when I highlight it, it changes the color scheme. It's the % thing, the dollar thing. The correct version uses $0, immediate operand. The incorrect version uses just 0 without the dollar sign, which means it is using a direct operand instead of the immediate operand that you should be using. So that's the second one. Most people spot the second one. The first one, about half of the class got it. The last part here has to do with, I pushed something on the stack. If you look at the code here, I have, these pop and the push instruction here, which means, during the execution of the loop, there's always, something extra on the stack. So that means, when you pop everything or when you're about to return, you will have to adjust, and use, for and adjust the stack pointer, differently. Some people just flat out deleted the push and the pop instructions, and as it turns out in this case that will still be correct. The code would not be affected, so I count that as a correct solution. Some people turn this last part into RET, which is okay as long as the stack is balanced at that point. Okay, so that means I'm not really looking for people to change it the way exactly illustrated here, as long as the problem is removed and the code is correct, it's doing what it is supposed to do, you will still get the credit. Are we doing okay so far at this point? Okay, so moving on to the next one. Okay, so the next one, okay, by the way, the div does not show, the entire code. If there's a huge section of code that is common between the two, it doesn't show that. So at this point, we want to take a look at line 123 of the correct version, which is missing from the incorrect version. I set up registers EAX, EBX, ECX, and EDX, and then what did I do? Nothing. Okay, so I'm missing the instruction which is int $0x80. which is sometimes what I actually do. I would set up all the registers and I forget to ask the operating system to do the operation. So that's one thing, okay? And then if you look down a little bit here on line 126, line 26 is JZ versus JNZ. I think about 85% or even 90% of the class caught that one. It's a conditional branch thing, and I was using the reverse of what is expected here. Line 127, again we have byte versus long, because in this case CH is a byte wide or 1 byte kind of thing. If you use a compare long, it's not going to work. Now some of you, when you wrote some of your previous programs, you used compare long where you should be using compare byte, and yet your program still worked correctly. And that's because a lot of people pad extra bytes after something like CH. If you pad extra bytes and those bytes turn out to be zeros, then compare long would work as well. In this program, there's no extra padding. If there's no extra padding, then if you use compare long instead of compare byte, then it won't work. Okay. And I think a lot of people missed the width, the operand width thing. Okay, they did not catch all the width problems with this program, which is something that I see in a lot of programs. So I was hoping that people would recognize that when they see something like this. Line 129 to line 131, basically the same thing. The correct version all use byte-wide operations. The incorrect versions, they all use the compare long, add long, and move long instructions. So once again, it is the width of the operation that is incorrect. And I basically classify all of these as one single error. So it's not like 3 points for all 3 lines. It is the same type of problem. Line 132 is a more obscure one. I think about 1/3 of the class got this one. The correct version is JMB, jump if not below. The incorrect version says JA, which is jump if above. They are almost exactly the same, except there's one case that is different. What if they are equal? That's the one case that is not the same, and the code would not work correctly if you do not use the right conditional branch instruction. About 1/3 of the class caught this one, but it's not like the other one. Some of the other ones are really easy to catch. We're down to line 139 to 142. Okay, 139 to 142 is considered one thing. There are many ways to do it. Okay, I just chose to do it this way, using add with carry byte and then add with carry word. But you can do it in many other ways. Some people just move everything into a 32-bit register, then do the calculation. That's good too. But basically, once again, we have a problem with the width, and also we are having 2 memory operands in the same instruction, which is also the second problem of this. Most people recognize that they are the first problem, but the second problem regarding the width, many people miss that as well. Are we doing okay so far with this? Okay. And line 143 is its own problem. Line 143 in the correct version is jumping back to the beginning of the loop. In the incorrect version, there's no branch back to the beginning of the loop. Okay, so that's one problem all by itself, is the loop is not done correctly because there's no branch back to the beginning. And then we have line 145, the missing return statement, or the return instruction. In the correct version, it is here. In the incorrect version, there's no return, which means execution will continue to whatever is after that, which is the entry point of another subroutine. Okay. Are we doing okay so far with these 2 subroutines? Okay. And the rest of this is just the implementation of the print-based subroutine. Do you want me to go over that, or do you want me to use the time to go over the previous homework assignment? I think the previous homework assignment will do you more good than this one. This one, is still not using, parameter passed on the stack. It's not using frame pointers and stuff like that. So, I can explain that, but you should be able to read the solution and understand, how you get things done. I did not use any tricks here. I was, just basically translating the C code line by line into assembly code in this case. So you should be able to pick out, okay, these few instructions correspond to this line in C, these few lines correspond to this line in C, and so on. Okay. Most people who attempted this one here, except for people who ran out of time, actually got a good amount of points because I was just identifying the major components of this subroutine, and I assigned partial credit to each component of the subroutine. Any questions about this? No? Okay. Now you can also do a vim diff and add one more file, which is your file. Vim diff can take up to 3 files and do a diff and compare of using 3 columns. So there's the correct code, there's the question code, and then there is your code, and it will do the same thing. Sometimes it doesn't work depending on whether you completely try to rewrite something or you move the comments a lot. Because if you move the comments a lot, the vim diff does not do a good job of synchronizing the lines. But for the most part, it does a fairly good job. Any questions about this question? No questions? Okay. Remember, next Tuesday, we're still meeting next Tuesday, and that would be the last chance to ask questions in the class. Okay, so we'll go back and take a look at the last homework assignment, not the current one, but the one that was due on Tuesday. That would be subroutine 2. And I'll just go ahead and do exactly what is asked to do here. I'm going to put this folder in my home folder. And what was the name again? Subroutine 2, like that? Okay. And my job is to implement, powers. Powers is the only subroutine in this case that we need to implement. This one is different from the current homework assignment in several major ways. First of all, the return value n is an integer. So that means we don't have to reserve any space for the return value because that only applies when you have to return a structure. An integer is a scalar, and therefore there's no need to reserve the space. In fact, the C compiler does not expect that. So this one is a little bit easier than the one that we have to do for this week. And we'll go ahead and this is line 28. I'm just going to my subroutine, my assembly version. I put my C code into the assembly version from line 3 to line 17. Insert the comment symbol. So this way I can interleave my assembly code, with my C code in between. Yep.
Can you turn on the line numbers?
Do you want me to turn on the line numbers? Sure. Okay. So we'll just go ahead and implement this subroutine. The first thing I always do, which is not something that you have to do, is to use the symbols old EBP equals 0. Now, do we have any questions of why old EBP is 0? No? That part is good? Okay. Because if there are any questions about why old EBP equals to 0, that means everything else is going to be completely lost. Okay. So we definitely need to understand why old EBP is 0 and why return address is old EBP plus 4, and then why we have B1 next to that, and B2 is after that. There we go. Okay. Are there any questions about these 4 symbol definitions? Okay, all of these symbols define a certain displacement from where EBP points to those particular items. I just decided not to use a very long name like offset to from where EBP points to da da da. Okay, so I'm just using a shorthand of those symbols. I'm going to preserve the meaning of the entire program, so I'm not going to take any assembly shortcut in this case. So I will also need my local variables in this case. Yep.
Don't you need the return value address in there as well, since you're returning in, or is your
No, because when you're returning a scalar, it is done by EAX. EAX returns, a scalar value, and you have to reserve the space if you're returning anything other than a scalar. Okay. And now we can deal with the local variables. The local variables, it doesn't matter. We can start with n. N is old EBP minus 4. And then we have CH, which is old EBP, n minus 4. 1 is okay. If you do an n minus 1, then the stack will not be aligned, quote unquote, aligned anymore. It will still work. Your program will still work, but the efficiency of your program is going to go all the way down the drain. Okay? It has to do with if the address of your stack pointer is no longer divisible by 4, then unless you're just grabbing CH, most of the operations related to the stack want to grab 4 bytes at a time. Call will push 4 bytes at a time, return will pop 4 bytes at a time, and so on and so forth. If the byte is out of alignment, then what used to be done in one single memory access will need 2 memory access. Because for each memory access to your memory, it can grab 32 bits. But those 32 bits must be 4 byte aligned. So if you try to grab 32 bits, but those 32 bits are not 4 byte aligned, then it will have to first grab one portion from one memory access and then grab the remaining portion from a second memory access. So that's why we want the stack to be always aligned to 4 bytes. It will still work if it is not. It's just not efficient to do it that way. Yep.
So sometimes it is good to waste memory.
Sometimes you can sacrifice memory for speed. Yes. Yep.
So if we are dealing with stacks, it's good always to use like 4 bytes at a time.
Yes. Now, if I have some other, byte-wide, local variables, I can pack all of those so that, I don't waste space, in that case. That's okay. But since in this case I only have one single byte-wide, variable, I cannot pack anything else to these to the other 3 bytes that I'm reserving here. So I am wasting 3 bytes, every time I invoke the subroutine. Okay, so all the symbols are defined now. We can go into the subroutine and actually try to start to do things. When you get into the subroutine, the entry code and the exit code should be boilerplate now. In other words, it's just okay, the first 2 instructions must be this, and then the last 2 instructions must be something else, or the last 3 instructions I should say. The first 2 instructions, the first one is always push EBP. The second one is always move ESP to EBP. In other words, EBP, we save the current value of EBP first so that we can restore that later, so that to our caller, it has never been changed. That's the purpose of the push EBP instruction, which is matched by a pop EBP instruction at the end. So at the end here, I will do the same thing, except it is completely in the opposite direction. Move EBP into ESP, and then pop L EBP. Okay, yep.
Does it matter if you do that before or after you do your labels?
It does not matter.
Okay.
You can put the label definitions all the way at the bottom, all the way to the top. It does not matter for the assembler. This is not C. I know in C, it really matters, where you put the definitions. But in assembly, language, it does not matter where you put the labels. And then the next thing we need to do is to reserve the space on the stack for our local variables. And to do that, we can just say add L, $, CH in this case, because CH is the last one that I defined, to ESP. So that will reserve, in this case, 8 bytes on the stack for N and also CH. So with all that stuff, allocated, I can now go in and actually, write the code for the C code. Sorry? Question? Okay. So the first thing we want to do is to move a 10 into CH. Okay, so we can do a move byte in this case. Now in this case, if you do a move long 10 into CH, it's actually okay. And that's because when I allocated space on the stack for CH, I actually allocated 4 bytes. So there's no chance, that move L instruction will mess up, in some other variables. So that's fine in this case. But in terms of correctness, it is still better to say that this is a byte-wide move, even though effectively it is still move long in terms of memory access. It still has to access 32-bit at a time. So I'll move 10 into CH open paren EBP. Okay. Basically, if I want to access my local variables or my parameters, all I have to do is to use that name using a base operand and use EBP as my base register. And I can do this, anywhere within the subroutine, even if I use, push and pop and change the stack pointer, all day long, because the frame pointer, which is EBP, is now decoupled from ESP. I can change ESP all I want in the subroutine, but EBP keeps pointing to exactly the same spot. And that's the reason why we have the frame pointer, because I don't want to have to keep track of the displacement from the stack pointer to the items that I want to access. The next one is initializing n to 1. So we have move L, L1 to n EBP. And now we have the while statement. Now in terms of the while statement, we know that we have to come back here potentially. So that means I should probably do a begin label here. So I'll say begin while. We only have one single while loop, so it's perfectly safe to use begin while instead of begin while 1, while 2, while 3. If you have multiple while statements, then you have to have a way to designate which while you're talking about. But since we only have one, we can do it fairly easily. And I would even go to the bottom of the loop here and just do a JMP to begin while at this point. So this means when I'm writing my program, I am not writing the program really sequentially. I'm writing the program structurally, not sequentially. Okay? Especially for loops, conditional statements, entry code and exit code and stuff like that, I always do it in a structural way so that when I start something, I immediately go to the end and finish up the end first. Then I go back and fill in the details later on. It's not something that you have to do. There's no way I can actually grade you on your programming style. I'm just saying that after 20 years or so of especially programming in assembly, this particular way of programming is helpful. Okay, that's all I can say. Maybe next time we will have video recording of everybody's work done, and I'll grade on style as well as correct.
You don't want to do that.
6-hour video, 1 hour working on it, 3 hours of sleep, another hour working on it, 20 minutes of lunch, 5 minutes to the bathroom, and then 40 minutes of doing.
We'll even have a panel. I would not be the only one. We'll have Iraj and Dave and
you guys won't get anything done.
And and we'll just okay, we'll show 5 minutes of clip of how this problem is solved, and we'll hold up like 10, 9, 9.5.
Iraj gets no say on my style.
Oh, this guy did not use VI, automatically 2 points off.
Emacs, you should be an automatic fail. We're supposed to use an editor, not an operating system.
Okay, so now we need to first call compare, because compare is going to return a value, so I can use that to compare to 0. But before I can call compare, there are several things I have to do. First one is I have to push n on the stack. Now, thanks to Intel, or thanks to the x86 being a CISC architecture, we can do something like this. Now, if this were not a CISC architecture, then we'll have to go through more trouble to do exactly the same thing. But, since we can't use this instruction or this operand, we'll just go ahead and use this operand. Next, we have to push n times b1 on the stack. Well, I'll just go ahead and perform the multiplication first, and then just push the register EAX after the multiplication. So in this case, we have, okay. So here's the part. Let me just write it first, and then I'll tell you guys what we need to do to fix that. I'm not using any tricks here. I'm just using a move instruction to move n EBP into EAX. And then I have to move the other one into EBX, or you can try this instruction here, to see whether mole will take a memory operand. I really do not know, but if it does not work, the assembler would complain. Okay, so I'll give it a try first. If it doesn't work, then I'll switch and use a register instead. After the mole instruction, both EAX and EDX are modified. Okay, but I only care about EAX because EAX is the least significant 32-bit of the product, which is what I need. I don't really care about the most significant 32 bits. So here we have EAX is something I want to push on the stack, and therefore I push, I just pressed the wrong key. No, it's there, VI is really good. Even if I crash the program or kill, VI, it has a quote-unquote, swap file. And the swap file basically has the very last thing that I do before I exit edit mode. Yep.
You had to preserve EAX before the mole. Did you do that already?
EAX does not need to be preserved. EBX needs to be preserved, but I'm not using EBX anywhere in this program yet. So that's okay. There's nothing to preserve. If you worry that EDX also needs to be preserved, we can go ahead and preserve that. So how do we preserve EDX?
Push EDX.
Well, the important part is where do we push and where do we pop? Okay.
After using.
We push it right before it is modified, and then we pop it immediately after it is used and no longer useful anymore. Yep.
Mole will work that way.
Oh, mole will change.
No, yeah, it'll work like that.
It will work like that? Okay. So there's no need to use EBX, but this way, I also preserve EDX. Now, for people who really don't want to think about, which register I should push and which register I should pop, you can always use push A and pop A. Push-A and pop-A. Yeah, but that's like really wasteful. That will probably get a style rating of 5 out of 10, if that.
From now on,
That should be default. You should be push A and pop A at the beginning and end of every function. Just automatically return to the function before what it wants.
That's just poor programming style. That's why Microsoft code is so bloated.
We'll just tell them we learned it from Tyler.
Okay, so we call the compare function, and then after we return, we'll add 8 back to the stack pointer because we want to adjust the stack for the 8 bytes that we took up for the parameters. Okay, the parameters are no longer useful from the caller's perspective. Now, at this point, what is important is what is in EAX, because EAX stores the return value from compare. So we have to compare that to 0. Compare long to 0, EAX. In this case, when you have a loop, you have to look at it, on the flip side. Basically, you have to ask, when am I getting out of the loop? Because it's easier to do it that way than to use this comparison, because then you have to jump around something, then you have an unconditional branch out. So we are branching out if EAX is less than or equal to 0. Okay, less than or equal to means it is not greater than. Now, the bigger question is, what exactly is EAX? Is it a signed number or is it an unsigned number? Because that determines.
It's signed.
It is signed, okay? If it is signed, that means we have to use the L and the G instead of the B and the C. So this way we have to say if EAX is not greater than.
I found that one out the hard way.
Then we have to branch to end while. Now, as soon as I type end while here, I would go and actually define end while down here. Because once again, it is a structural thing. If I know, how I can get out of the loop, I should define the label immediately so that, one, I do not forget. If I forget to define the label, it's not a big deal. The assembler and the linker will catch it eventually. However, by the time the linker catches that, if I have a long subroutine here, it will take me a while to figure out, where that label was supposed to go.
That was a bad joke.
What?
It'll take you a while to figure out what the label is.
Oh, ha ha. That's a good one. It was not intended.
Well, obviously.
Okay, so now we can go back and actually deal with the middle part of the loop. we have to call print-base with B2 and N. This is a really easy one because you just push B2, open paren, EBP, and then push L, N, EBP, call print-base. When it returns, you have to add L, $A to ESP to readjust the stack, and that's it. As for the write operation, you have a choice. If you want to, you can actually call write, and it will work. If you don't want to call write, you can just go ahead and set up EAX, EBX, ECX, and EDX, and then use the software interrupt. That will work as well. So you have a choice here. Which way did you guys use?
Called it.
You just called it? Okay, you just called it. Well, either way, you have to figure out, how to figure out the address of CH. So I have to illustrate that, regardless of which approach you use. But this one is actually easier, okay, because I don't have to put it into registers. Okay, so now we are dealing with the ampersand of CH, which is the address of CH. If I did something like this, why would this be wrong?
This is the value of CH.
This is the value of CH. So that means the instruction is doing a little more than what I need, okay? Because not only did it compute the effective address, it did the dereference, which is something that I do not want to do, okay? So I actually have to do this a little differently. I have to push EBP first, and then add $CH to what I just pushed on the stack, and this will calculate the address of CH open paren EBP close paren. Because that's basically what a based operand does. Base operand is just adding the constant outside of the parentheses to the value of the register that we know as the base register. And I'm just doing the addition explicitly in this case, and also push it on the stack at the same time. Okay. So that means I have one more operand, one more parameter to push, or one more argument to push, which is the last one. And then I call the write subroutine. When it comes back, I have to deallocate 12 bytes because there are 3 4-byte things on the stack at this point. That's my write instruction. And now I have to deal with the multiplication thing. Now, if you did something smart earlier, you could have saved this value a little bit earlier and reuse it here. Okay, but I'm not doing that because I don't want to use any tricks in this case. So I'm just going to redo all the calculations, which is not a big deal. Moving n into EAX first, mol B1 EBP, and then the result is in EAX. I have to move EAX back into n. And if I worry about the destruction of registers, anything other than EAX, I can just do a push L EDX here and do a pop L EDX here. I don't think EDX matters, okay? So I don't think this is necessary. But I'm just illustrating how to save and restore a register if you need to preserve that value. Are we doing okay so far? Okay. And the loop is all done. The only thing I have left to do is return n. Return n is just move n EBP into EAX, because when you're returning an integer, a pointer, or any type of scalar, you are using EAX to return the value, and that will specify the return value. So unless I mess up something and you guys miss that too, I think this will work. Let's go ahead and give it a try. So we say make, and then we'll say main 799, and it worked. Now somebody pointed out, someone actually looked at the code and go like, oh, but it's not actually correct because someone did this. Okay, so you're using. I'm trying to display powers of 10 using base 10 and base 10. Okay, and you will see that this is actually incorrect because the program is actually faulty. The last one, it should have stopped here, because if you look at the number of zeros, we have 9 zeros here already. This is 1 billion. Which is the last power of 10 that can be represented using 32-bit unsigned. It did not fail that because when it wrapped around, that number turned out to be greater than 1 billion, which is my fault of not taking that into account. So I'm not going to use this one as a test case to cover my own track.
Oh, hey, we should get the same results you did.
Well, if you did a complete translation, just a literal translation, yes, you should get this one, but some people in the class actually fixed the program so that it would not do this.
Wow, as long as they did exactly what yours did, that's all that matters.
They're trying to be tryhards.
Okay, so are there any questions about the solution of this of the last homework assignment? It's not really just the solution itself, because I could have just do this and show you the code or tell you where to find the code and call it a day. I want to show you how I actually approach the problem. Okay, many of you probably will not have a chance to write assembly code anymore, so this is all irrelevant. But I think even in C code, it is still helpful to think about the structure of the code first, and then go back in and fill in the details later. Okay, I think that's just a useful approach, especially when you have nested structures. Then it is always useful to think in the structure instead of a line by line, type of basis. All right. So we are done with this. What else do we have to do?
That's it.
We should be free to go,
I
right?
think that's it.
We still have another half hour to go.
But if there's no
Can we go to the
material
lab
to
early?
cover,
That would be
Go
great.
to the lab early.
I'd love to go to the lab right now.
In terms of the current homework assignment, are there any questions?
Yeah, can you start with the dot start section? Start roll. That's how far I got.
I got
No attempts this time.
Try to work on this as early as possible because next Tuesday is our last meeting, but the homework is due on Wednesday. Okay, so that's why you should use next Tuesday, which is next Tuesday is extra time because we usually only have 1 week to work on homework assignments, which means there's only one class meeting to ask questions. This time you guys have 2, and there are 2 lab sessions as well if you want to show me your code, and I can help you in the lab, to help you debug your code. But your code has to be runnable in a debugger before I can even take a look at it. Okay, so that's
Right.
kind of like a implied condition, In other words, I cannot really just look at a piece of paper with with the source code and identify problems because the debugger, as you guys have found out, is a very useful tool. I can use the debugger to really help identify problems. Okay. What I really want to say is, my brain is a very poor emulator. I look at the instruction, I try to execute in my head, and I cannot add the stack pointer correctly and stuff like that. So it's better to use the machine to do it. Okay, so let's go ahead and take a look at the homework assignment, BST. And you can see that, make works because, everything is self-consistent. And there are several things, there are several questions people have asked already, so I would just kind of go ahead and address, some of those questions. The first one was, the first question is something like this, okay? If you go to bst struct.c, it is currently empty. If you try to use, struct bst node in here and try to do a pound include bst.h, it will give you an error immediately. And that's because one of the types is missing.
You get 32_t.
Yep, in32_t is missing. So how are we going to fix that?
Do you pound include std at live?
Well, but how do we know that will fix the problem? That's the thing. I mean, we don't.
Because there's only 2 files in your main one that you're
Exactly.
including, and only one is included.
Exactly. So this is why you have to look at the code here to figure out, okay, what am I including here? I mean, if you want to include stdio.h is already included in bst struct.h, is it or not? It's not? It is. I think it is.
it's the only thing
No.
included.
It is the only thing included. So the other 2 include files, is the only thing. I mean, if you want to fix that problem, it has to be one or the other. bst.h is not optional. You have to have that one in bst struct.c. So the only one left is stdint.h, which defines integers so that when you say int 32_t, it guarantees that it is a 32-bit signed integer. Because if you don't do something like that and you take this program and cross-compile that, let's say in a 64-bit platform, int becomes 64-bit. If you take that program to a 16-bit platform, int becomes 16-bit. Okay, so you don't want to use int, carelessly. We can do this here because we are all running from the same emulator, and the emulator is a 32-bit, emulation. So it works. But in general, you should always use, the int32_t to make sure that it is of a certain width when the width is important.
Can you write a command out what you just said? The underscore of the 32.
I don't think he wants to see it.
You mean you haven't seen this one yet? The int32_t? And I think you might be able to man that too. Nope, it does not. I probably just did not include the proper man files because I think it is actually a part of the man pages. It's just that you have to include the right file to do that. So that would be the first step, and then you have to, someone asked me to go through the steps, to do this homework assignment. So the first step is going to do something like this. You go to cisp310 in assembly language programming. 2.2. You have read it enough times to remember the actual section number. Very good. Okay, so the first thing you have to do is to read this part here and figure out how this relates to the homework assignment. And you have to make sure that this part works first, okay? Because if this part is not working, there's nothing else you really can do with this program. So you got to make sure that this part is working first. So assuming this part is working, now how do you know this part is working? When you say make, when you say make, if this part is working, then you can log into bst.inc. It should not be empty anymore. It should be populated with bst node underscore blah equals something, and so on and so forth. Okay, so all the constants and all the symbols that you need to access members of the BST node type, as well as the size of the BST node, should be defined in this file if you have that program done correctly, if you have the C program done correctly. If you have it done correctly and you type make, you should not see any assembler errors either. Okay, let me show you what I mean by, if you did it right, there should be no assembly error. So I'm just going to do this intentionally incorrectly. Sometimes I do things incorrectly, but it's not intentional, but this time it is. Okay.
Say that now.
Tag sometimes.
You probably should find it my code, don't worry.
Mistakes.
Likewise.
Okay. So what this is doing is, you don't have to have taken the C class to kind of guess what this is going to do. This is just going to print that string to standard out. Okay. But then if you look at makefile, you will see what we do with the standard output of BST struct. We just capture that into bst.inc, which is the include file that we use inside bst.uppercase-s. So we look at BST.
That's going to be one heck of an invalid label name.
So in here, there's no pound include. So that means if I say make, hey, everything is still good. But that's because I am not including that file yet. So you have to make sure that your assembly code has a pound include, just like with your C and C++ programs, to pound include that file. Kind of like something like this. Okay? So once you have this one, and if the syntax of that file is incorrect, the assembler will complain. Okay, so the first hurdle is to get this part done, make sure the include file looks reasonable with all the definitions that you need. Then you can move forward to the next step. The next step then is to implement the subroutine. Okay. Any questions at this point? Nope. So we talked about this a little bit on Tuesday too. When you try to implement the subroutine, I would not try to implement the whole thing all at once. Okay, I would leave this up to you. Okay, because at this point, pound if def c imp actually includes this commented section, or not commented, but the conditional compiled section include both add BST node as well as default BST node. So that means you have to implement both of these subroutines in assembly. But if you want to only have to deal with one at a time, you will have to make some changes to the make file because the make file is not designed to handle one or both, in assembly. So you have to make some changes to the make file. I can show you how to do that because it's all recorded. You can basically just replay this section, once the YouTube thing is up and running. And the current time is 8 o'clock, so about 1 hour into the video is what you need. So if I want to write down like 1 hour in the video.
Or just write down what you're doing.
Or you can do that. Okay, so the first thing you want to do, let's say we want to deal with BST, default BST node. I just moved my pound and if earlier so that the conditionally compiled section is now just one single function. Okay? Now that will work okay, but it will require one change to the make file. Let me show you what happens when I don't make any changes to the make file. If I say make, it's not happy. It's not happy because now I have two implementations of the same function. Okay? Default BST node is now defined twice, one in BST.c and one more time in default BST node .uppercase s. So the easiest way to do it is not to fix the make file because if you mess around with the make file, it is possible that you would have forgotten how to restore that.
Can you just rename the default BST node
Yep.
lowercase s?
Yep, this will be the easiest way to do it. You just basically, you can comment it out.
Oh,
Okay, you can just comment it out. If you comment it out, there's no way that the change label will confuse you later on when you actually try to implement it. So this will fix that problem. Make everything is good. So in this case, we are only using the assembly version of add BST node, and the other one is now still implemented in C. So you can use this trick to only have one of the two subroutines implemented in assembly. So this way you can concentrate to debug only one subroutine at a time instead of having to deal with both at the same time. Okay. Any questions about this step here? It's just a little trick, you can just change, so that the label is no longer defined in the assembly code. Okay. So let's take a look at BST.c again. This time we're concentrating on that one single subroutine that we have to implement. It looks kind of bad because it is a fairly long subroutine, when we look at the C version. Remember what I said on Tuesday. Do not try to implement this whole subroutine all at once and try to debug this whole thing all at once. Only do it one step at a time. Okay, just do it one step at a time. I would just implement everything up to line 33 initially. Okay? If you implement everything only up to line 33, then obviously the program is incorrect because it will only populate one single node in the binary search tree. But at least you can try it. You can try and make sure that it works. Because if that step does not work, there's no point in continuing with the rest of the code. So I would do it one step at a time. Now doing that is not pointless, or it's actually fairly complicated already. If you look at line 30, okay, let's start with line 29 or line 27.
That's right.
Okay, if you look at line 27, we are not comparing null, which is basically just 0, to one of the parameters. We're comparing 0 to what a parameter is pointing at. Okay, we talked about this on Tuesday. I actually illustrated the actual code to do something similar to that. So you have to kind of go back to that code and make sure that you can read that part and understand it. But once you know how to do this, the second part, which is on line 29, is about the same thing, except this time you're not using the value to compare, you are storing to that location. I think on Tuesday we talked about this too, how to dereference something or store something to an address that is dereferenced from a parameter. Okay, so that part is done. And then you have these two lines, line 30 and line 31 are pretty much symmetrical. If you know how to do one, the other one is really similar. And then we have the last one, which is just return 1. If you don't want to use added as a local variable to store the return value and only return that at the very end, If you just do a return 1 here, the program would work just as well. Okay, so I would debug the program only up to this point. Write the program only write it up to this point. When you test it, you just need one single number. You can give it a whole bunch of numbers, but only the first one is going to be stored. Okay, but at least you can test it. If the program works, it does not crash, then you can move on. If the program crashes up to this point, then you have to fix it up to this point first. Okay, so my point is, don't try to write the entire program all at the same time, all at once. Just do it one step at a time. Are there any questions about that approach? That really does not apply only to this class. It applies to just about any programming class that you take. Or when you do work, at the workplace, it's the same thing. Don't try to write any more than. It depends on your proficiency. When you're a student, maybe 5-10 lines or so. But when you go out to work, you may be able to write 20 or 30 lines without actually worrying too much that those 20 or 30 lines would introduce too many errors. But nonetheless, you want to make sure that you don't try to write the entire thing all at the same time. Now, if the program works all the way up to line 32, then you go ahead and try to implement it a little bit more. And I would implement it up to line 40. In other words, we only deal with one side of the tree and not to deal with the other side of the tree. We talked about this on Tuesday as well. Basically, in this case, you have to give it numbers that are only decreasing in terms of ordering, and make sure the program works in that case. If the program works in that case, the other half is basically just mostly copy and paste, because we have about the same thing. The function call to add BST node is about the same thing. If you know how to deal with line 39, line 43 is really about the same thing. Are there any questions at this point? No questions? This is all good? Nap time? Dinner time? Homework time?
Lab time?
Yeah, lab time.
Lab time. Are there any other questions about this one? Because this one is a little bit more involved than some of the other homework assignments. You just have to do it one at a time, or one step at a time. Okay, let me just do one more. Yep, go ahead.
I'm confused on line 27, the star P tree.
Uh-huh.
I followed your notes, but I wasn't, for some reason, getting I could never get null. And so I wasn't sure if I was dereferencing properly, but can you kind of explain that part again?
Okay. Now P tree is the parameter itself.
Right.
P tree is never null itself. But what it points to may be null. So what you need to do is to get the parameter, but the parameter is not what you want. It is what the parameter pointing at that is what you want. So you need one more dereference before you can compare. You have to take whatever P tree is, which is your parameter, stick it into a register, pick one register. I would pick EAX because EAX does not need to be preserved, and then dereference EAX to get to the actual thing that you want to compare.
I'll have to look at it.
Okay. I think on Tuesday we have one example similar to this.
And I followed it, but I wasn't getting the right answer.
Yeah, right
There was four
right
of
off
us
the bat,
tried it.
it would never be null with nothing in there. It would always have a value in there once you tried to compare. So when you compare against 0, it would never actually be 0 the first time through.
No, it would, because because of the way I initialize everything. Okay, see in the main code here, tree itself is a pointer, but I make sure that that pointer is pointing to null. Okay, now, no, so this is the first part. Okay, when this is not working, and we use the whiteboard. Okay. First of all, let's see what is tree here. Okay, so if you look at the local variable tree in main, it's a pointer. But this is a pointer supposedly to point to a structure of BST node. Is that okay? But the initialization that I have here is saying that it does not point to a structure. And sometimes, when people say that it points to a null, they just use a ground symbol. Is that what you use to represent it as pointing to null?
Good enough.
Good enough?
I get it.
Knowing that that's what you're using, it will suffice.
Okay, so this is what I use to represent a pointer is pointing to null. It is quote unquote grounded. When you look at the rest of the program, okay, we're dealing with the first iteration, okay, because if you only implement up to that first part, only the first iteration counts, because all the subsequent iterations will try to put stuff to the left or the right node, so it's not going to work. So you want to look at line 94. Line 94 is not passing tree itself, it's passing the address of tree. So your parameter, which is called p tree, a pointer to a tree, is a pointer to a pointer that just so happens to be pointing to null at this time.
That makes so much more sense now.
So we have to
does?
implement add
Yeah,
BST
it makes more sense to me.
Sorry?
We have to implement add BST node first, don't we?
Yes.
In order for that to work, because I was working on the other one.
Oh, you were working on
That's what-
default
that's-
BST node?
Yeah,
Right.
Okay, if you're working on default BST node,
'cause that's where the code was at.
okay, now default BST node can be debugged, but you have to make changes to main to debug that easily. So what you need to do is, okay, let's take a look at the default BST node. Default BST node is going to return a BST node that has certain things initialized to 0, right? That's basically what it's supposed to return. So if you want to test just default BST node, the easiest way to do it that I can think of is to do something like this. You just say, struct BST node, test, and then in your code, you just say test equals default BST node, like that, and put a breakpoint right there. Okay, if you put a breakpoint in this program on line 96, then you can go ahead and test, you can print test, and the debugger is smart enough, if you're trying to print a structure, it will print out the values of each member of the structure. Then you can see whether it is done correctly or not. So this would be a quick and easy way to debug default BST node. But you do have to change main, or if you prefer, you can write a separate program to debug that. I would just kind of attach this code here. Just make sure you remember what you added to the main program, so you can undo that later. This change here is fairly benign. It doesn't really change the logic of the programs. It doesn't change the output of the program. So even if you forget to delete line 92 and 94 at the end, the program will still behave the way it should behave. So if you forget to delete it, it's not going to be the end of the world.
So if we do that, then will trees, trees still know what there, so we're fine. Okay.
Right, but you do have to put a breakpoint at line 96 so that it doesn't get to the part of the program that is not implemented yet.
Do you need to have a double equal sign or is that?
No, an equal sign. You can, if the left-hand side and the right-hand side of an assignment are exactly of the same type, the assignment will happen just fine.
Or if you have a correct overloaded operator.
Or if the left-hand side is a superclass of the left-hand side,
Yeah, parent class.
of the right-hand side, yeah. Now, how do we implement that in assembly?
I don't even want to know.
It just automatically has been implemented for us.
Yes.
How do you do an object in assembly? Or a class?
Well, you want to take cisp310 when I'm teaching it, because that's exactly how I teach that class.
Oh, no.
I look at C++ code in object-oriented way, and then I say, okay, this is C++. How do we do that in plain C? Now, sometimes, it's not possible because the C, when you run the C compiler, it does not have some of the information that is available to a C++, compiler when you define, classes and stuff like that. But you can come pretty close to, doing exactly the same thing, even with virtual functions and, polymorphism. You can still do that, implementing only in C, but it's a little bit messy, sometimes. Now, if you can do it in C, after this class, you can do it in assembly as well. So we can literally write C++ programs in assembly. when you combine 400 and 310. First stage rocket and then and the second stage rocket, right? We can get to the moon, that's fine, we can do it. Any other questions? No other questions? No one cares, how to implement, virtual functions in the assembly?
It's not too hard.
It's not
We
too
could
hard.
figure it out if we
There's
tried.
there are a lot of pointers involved. There are a lot of pointers involved.
I think next Thursday we should talk about that.
Add that to our current homework assignment.
his
Require
idea.
that we figure it out on our own by Wednesday.
Well, so my last word is, to try to work on this program as soon as possible, because knowing some people, oh, it's due on Wednesday, great, I'll start on Wednesday, in the morning. It might work for some people, but I'm just thinking for most people that would be like cutting it a little close.
No, in the morning I gotta work, so I'll start it in the evening.
I'll be done by class time, don't worry.
No, but.
Looking at the way that you did the assignment.